So our do now, we have a triangle with sides A, B, and C, and we want to choose which statement about the side lengths must be true. So take a second, pause, try and go. Reason I chose this question is because I think it's a really bad question. So I kind of wanted to model how do we process through something that's a bad question. So when I looked at this for the first time, I saw, oh, this is going to be a triangle inequality question. And I made that assumption, which I think is a pretty safe assumption. And I remember, oh, triangle inequality, that means the sum of the two shorter sides is greater than the longest side. But they didn't use those same letters, right? Here, the long side is B, and our short sides are A and C. So for this triangle, it wouldn't be this. It would be that A plus C has to be greater than B. And I go and I look for that answer choice, and it's not there. It's almost there with D, but that's not it, right? Because it doesn't have the right inequality symbol. So it's not a triangle inequality question. So what are they trying to get at here? Well, they're just kind of trying to get a relationship between the sides. So if we look through our answers, I'm going to go backwards. D is saying that the sum of the two shorter sides is less than the long side. That's not true. We know that because of the triangle inequality. And then C is saying if you take a short side and the long side and add them, that's going to be less than the other short side. No. B is saying that the long side plus one of the short sides is going to be less than the other short side. No. The only reasonable answer is A, saying that one of the short sides plus the long side is going to be greater than the other short side. Okay? So lesson here really kind of is, even if it's not a great question, there's still the correct answer on the page. You kind of have to take yourself out of the question to figure out what's going on there. Okay? So we're going to continue working with some geometry here, starting with some of our triangle geometry. So our triangle inequality, again, like we just talked about, A plus B is greater than C. So the sum of the two shorter sides is greater than the longest side, and we're on page 42 here. So I'm just going to use that to test to see, do these sides form a triangle? So we're looking to see, is 10 plus 10 greater than 20? And it's not, because it's exactly 20. So we say no, these do not form a triangle. We've got 15, 20, and 18. Shorter sides are 15 and 18. Is that greater than 20? Let's see. Well, 15 plus 18 is 33, which is greater than 20. So yes, it does form a triangle. Now, more specific, our Pythagorean theorem, which only relates to our right triangles. And when we have right triangles, the two shorter sides are called the legs. The longest side is called the hypotenuse. Our Pythagorean theorem says that the sum of the squares of the legs is equal to the square of the hypotenuse. We can use this a few different ways. One is by using it to determine if side lengths form a right triangle. That's what we're going to do with this first example. Look at, do these side lengths form a right triangle? So we're going to use our Pythagorean theorem. A squared plus B squared equals C squared, where A and B are our legs, so our two shorter sides. We'll do 5 squared plus 12 squared, and look to see, is that equal to our hypotenuse squared, 13 squared. 5 squared is 25, 12 squared is 144, 13 squared is 169. So 25 plus 144 is 169, so they are equal. So yes, it is a right triangle. Okay. Another way we could use it is if we're being given a right triangle. I know this is a right triangle from the right angle in the corner, and we're asked to determine a missing side. So again, we're going to use our Pythagorean theorem. I notice my missing side y is the hypotenuse, so that's going to go in for c squared. So we'll do 7 squared plus 9 squared equals y squared. 7 squared is 49. 9 squared is 81. That's going to give us 130 is equal to y squared. Now we take the square root of both sides. I'm going to round to the nearest tenth. We weren't given any direction, so I'll just do the nearest tenth. And that'll give us 11.4 is our value of y. Okay. Another type of question, finding a different side of our triangle and also having to draw a picture. A 20-foot ladder is leaning against a house. The bottom of the ladder is 3 feet from the house. how high up the house does the top of the ladder reach? So we've got a house, the ladder is 20 feet tall. It's 3 feet away from the house, a ladder against the house and the ground are gonna make that right angle. How high up does the ladder reach? That would be our x. We've got a right triangle. We can use our Pythagorean theorem. Our legs are going to be 3 and x, and our hypotenuse is 20. So it'll be 9 plus x squared equals 400. So x squared equals 391. Take the square root of both sides. This time we're given rounding instructions of the 100. And that'll be 19.77 feet. On the next page, we're going back to 3D geometry. We're going to look at the volume of the truncated cone. We had done this earlier in the year. I've only seen one example of this on the state test, but you never know, it could happen. So we want to remember that our truncated cone all has to do with the ratio of the radius to the height, where this height of our top missing cone, x, we don't know it. So make a ratio. 6 to x is equal to the radius of the full cone, 9, to the full height, which would be 10 plus x. Then we can cross multiply. 6 times 10 is 60. 6 times x is 6x. And that's going to equal 9x. Solve for x. 60 equals 3x. Divide both sides by 3. We get 20 equals x. And then we'll also want to know the full height of the cone, which would be x plus 10, which gives us 30. Now that we know the heights, we can figure out the full volume, so the volume of the full cone, and the volume of the top cone, and then we're going to subtract them. So volume formula for our cone is pi r squared h divided by 3, or you could do 1/3 pi r squared h, whatever you prefer. Okay? So let's start with the full cone. Radius of the full cone is 9 inches. The height, 10 plus x, is 30. Okay. So 9 squared is 81. Now 30 divided by 3, I know that, that's 10. So our volume of the full cone is just 810 pi. Volume of our top small cone, radius of our top small cone is 6, and the height we found was 20. 6 squared is 36. 36 is divisible by 3. 36 divided by 3 is 12. 12 times 20 is 240, so 240 pi. And then we just subtract. 810 pi minus 240 pi gives us 570 pi. We're going to have to leave in terms of pi, so now we just need units. Inches cubed. 570 inches cubed. It's 570 pi inches cubed. Last question, we're asked to determine the volume of a composite solid. So I see that's a full cylinder with sort of an inside cylinder carved out. And we're going to show all our work and leave in terms of pi. So 2 cylinders, we've got the full cylinder, and then that inside or that small cylinder, full cylinder, so both pi r squared h. Okay. Notice though that they give us the diameters, not the radius. We have to know if the diameter is 8, the radius is 4. If the diameter is 4, the radius is 2. And they both have the same height of 12. So our full cylinder, radius is 4, so that's going to be 4 squared times a height of 12. So pi times 16 times 12. So 192 pi. And then our inside cylinder, radius is 2, so 2 squared times 12. 2 squared is 4. 4 times 12 is 48. 48 pi, and then we're going to subtract because that inside one is carved out. Okay, so when we subtract 48 pi from 192 pi, we get 144 pi inches cubed. Okay. If you look on the next page, I gave you a copy of what the reference sheet is on the state test. So those are the formulas they give you. They give you some conversions also, which I don't think I've ever really seen used. We've got some geometry questions, and then I also went and I put in some stats questions. Right, so we want to be working on the rest of the booklet, any problems you don't have done, and at the end of class, you should be giving out the homework. Anybody who has to borrow a calculator should come and see me at X period.